So today, inshallah, we'll talk about the activity diagram and how it is work, and how we can draw the activity diagram as well. So the activity diagram is just another diagram similar to the other diagrams. It shows the flow of the system and how does it work and how it is work. So basically, it is what? It is just a business process. Consists when you have an application, the application will consist what? Number of process, and this process is more like steps that your program or your application will do. Now the activity diagram will visualize the sequence of this activity and show in sequence how this activity will be performed. So for example, it will tell you what? It will tell you that let's say that it will tell you that you start your program like this, and then you did the login, for example. Okay, login, and after that you did the registration, something like that. It shows you the flow of the process, how the process is going to happen inside your system. It is an abstract class, and it describes the process in general. Not too much detail should be mentioned in the process, just the general process one. Okay, the model behavior independent of the objects. Okay, it is independent of the object. Okay, it can be used for any type of process. You can use it to draw any process in your system, no matter what is it. Okay, it looks like a flowchart if you know what is the flowchart before, but it is actually is not a flowchart. Okay, the activity diagram basically describe the operation of the system. What are the main operation of the system? Similar now in the use case, you used to draw what? In the use case used to draw what? Used to draw a number of use case. Okay, number of use case. Now in the activity diagram, you need to take this use case and draw what? And draw this use case and draw a activity diagram for it. For each process, you will have an activity diagram. Okay, so it is not specify in detail what happened exactly in the process, but it shows the general way to process that. Anyway, these are the diagrams or the symbols that we use when we draw. So this one, it looks like a potato or oval or something. It represents an action. Okay, it could be not just one action, it could be more than one action in the same one. So when you have a login is an action. Okay, so you draw something like this and you say what? Here, login. So it represents an action. Okay, an action. Now the arrow is the flow from one to another one. You use arrow, okay, to show that we are going from this step to this step. The initial node, always when you start your diagram, you have to put this initial node, always. Okay, it's filled circle, and then at the end node it looks like this. Okay, filled circle, but there's another circle around it. This is the end node, the final node. And if you have a decision, you need to draw this one and write the decision of this one. For example, login is okay, correct password or not. If it's a correct password, you say yes. If it's not a correct password, for example, you say no, and what you do in each decision in any way. So this is basically how the symbols that we are using in drawing the activity diagrams. These are more explanation about these diagrams. So we talk about the initial one, we talk about the final node, and we talk about the decision. We have the merge. Okay, sometimes you have when the program perform. Okay, the program perform and it make a decision somehow to go there and make a decision for yes or no. Okay, and then at the end, this one will perform some operation and continue. The output from both of them goes into what? Into a merge. They merge together to continue the programs. You can use also fork node if you have one operation that operation will be split into two operation. Okay, you will be you need to use what? You need to use the fork. The fork looked like this. One process is split into two process. They will be executed at the same time. And the opposite, if you have two processes who are executing at the same time, they will be joined into what? Into one process. This is just a simple. And we have Swimlane. Swimlane, you put similar, break the diagram into lanes. Okay. So for example, you can say like this. For example, this is for the user customer. Okay. And this is for the system, for example. So we have two lanes. Okay. These lanes, and when you start the system, the customer will start, for example, and the customer will do the login, for example, like this. Then the system will what? Will check the login. So it is the same diagram. We just split it into what? Into lanes. Each lane, for example, for a user, or each lane for a specific things, and so on. So the lanes are just more like classification of the diagram and split it into pieces. When you make a decision, for example, this is the decision. You say this is the temperature. Let's see if the temperature is cold or hot. Okay, if it's too hot, this is for the condition, for example. If you want to turn on the condition. If it's too hot, I'm gonna say cool down. If it's too cold, I'm gonna say heat up. So you make a decision like this way. This is an example of the merge node. So for example, this is the start node. You can see that. This is the start node. So this is for the order, for making an order. Okay, this is for making an order. So he placed an order. This is a verb. He placed an order. This is an operation or action. Now this order will go to a decision. Okay, if the order item is available in the storage, okay, then we have an action. The item is available. Okay, we have to continue process the item. And if the item is not available, okay, we can order the item from somewhere else. Okay, order the item from somewhere else. And then at the same time, these two operations will be merged into same line. Okay, will come up to the same line. So this is merge. This is what? This is not a decision merge. And the decision is like this. Okay, decision is the arrow coming out from the decision. Okay, the merge actually, the arrow is coming into the simple. So this is called merge. This is the decision. All right, and now this is the merge. The output from both of them goes into the one line, and then we have a decision. You see the arrow is going into the simple. That means we have a decision. So the decision, there's two arrow coming out from it. Now the first arrow, you need to order more item, then we have to go the process again. If there's no more item to order, then you go and process the order, and this is the final simple node. So this shows exactly the main steps that you will do when you make any order. You place an order. We check if the item is available. If the item is available, we add it to the basket. If the item is not available, then we have to order it from somewhere else. And both of them, we have to decide. Then you decide you want to order more item, or you just want to finish and that's it. So if you finish, then you have to go and process the order, make the payment or whatever, and then that's the end simple here. That's the final node of it. This is, for example, another example. Okay, if you have going to the library, okay, and you want to check your balance in the card, because there is some library somewhere that people they can borrow books and or buy books or something like that, and they have cards. So when you go to this is the start node. This is the start node here. Okay. And here we have scan library card, scan the library, and when you scan the library, there's a process called check balance. Okay, and this check balance is a process. So if you want to use the use case could contain what? could contain the process called what? Pay fees. Okay, pay fees. This is all pay fees. So when you check the balance, it goes to what? It goes to a decision. You check if there is unpaid fine or no fine. So if there is unpaid fine, you have to pay the fine. You have to do this process. If there is no fine, then you do nothing. And both of them will be merged. This is a merge because the arrow is going into what? Into the simple, and scan, assist, and then that's the end of the process. Okay, so this is how, in a simple example on using that things. This is, for example, here scan assist could be split into two processes. We can split it into two processes, and this process running together at the same time. So, for example, you can make assist as checkout, or add assist to the pattern count or something like that. And then after they finish, they will what? This is the fork, and this is the join. The fork is splitting one process into two. Okay, this is the fork. It looks like a fork. You know the fork that we used to eat? It looks like a fork. Okay, it could be more than two process. It could be 3 or 4 process. The join is the opposite. Okay, the join is the opposite of the fork. They have two processes coming up, and they will come into one process. Okay, they will come into one process. This is the fork, and this is what? This is the join here. This is the Swimlane, as I explained before. This is an example of the Swimlane. You can split it into the users to specify the responsibility of each one. So this is the first LAN, and this is the second LAN. This LAN is for the first person or the user, and this one for the second user. So the process start here. This is the start. Okay, and when it start, both of them have to start. Both of them will do some operation, and this operation will join into two operations. For example, this one get the jelly, get bread, and this one will do get drink and get dessert, and then they will join into one operation. At the end, it will go to the second person. The second person will create lunch, check lunchbox, and put the lunchbox, and that's the end. You see, this first person has no responsibility about the lunch. He has only responsible about getting jelly and getting bread and getting a sandwich. But the lunch is creating the lunch, and these things are responsibility of the second person. Similar what we said, when you log in, a student can log in, okay, and the system will check if the student credential or password is correct or not. This is another example of the Swimlane. You have the manager, you have the accountant, and you have the client. Okay, each one has a swimming lane. The program or the process start with the manager. He record completion of the campaign, and then after that goes to the accountant. The accountant will issue invoice. This is his responsibility, and then the client will pay the invoice. Okay, this is the client responsibility to pay, and after that it goes to the manager who will record the client payment, and that's the end. Okay, this is the payment thing. So 3 users, and each one has its own responsibility to do something. This is an example of the activity diagram. Another example. So for example, here you request an order. Okay, you make a request. Now the company, to process the order, the company will receive the order. This is the start actually. Okay, this one is not counted. So this is the start here. Okay, this is the start. So the company will receive the order, and it will goes to what? It will goes to a decision. Either you accept the order or reject what? The order. Okay, either you accept the order or reject the order. If the order is accepted, if this so go with the order accepted. If the order is accepted, we're gonna fill the order, and then we will have to do 2 things together. This process and these two. So we're going to ship the order. At the same time, we'll have to send the invoice, make the payment, and accept the payment while we are shipping the order. So these two processes are together. See, two process, okay? This is more than one process will be running at the same time with what? With the shipping order, group of process, and it will goes to what? It will goes to join. Okay, the join for what? If the order is rejected, we are not going to do. If the order is rejected, it will come up here. If the order is rejected, if the diagram is too long, you can put the A, and you can put A on the second page, for example, to continue. But here we're on the same page. You can draw the line directly. No need for A. So if they rejected, then no need to do this fill order and ship and so on. We just go and close the order because the order is rejected. If the order is accepted, we have done the fill order, we have done the ship, we have done the payment, and then we are going to close the order. This is the last process, and this is the end node. This is all right. Another example of diagrams. For example, here for the clinic. Okay, you want to make an appointment or something. So let's start. Here the start node, get patient information. Get patient information. Okay. Now after, forget about this. Get information, patient information. After that, you go to a decision. Is it a new patient, or is already a patient here? And is he come to the clinic before? He has a file, or he's new, no file for the patient in the clinic. If he's new, he need to create a new patient file and make the payment and create an appointment if he's new to the clinic. If he's an old person, then we have to say, if he has a new information, then we need to update the information. Okay? If there is no new information, it's old information, the same information, then continue. So you have here joined. You have here join. Join, to use it when you have two lines coming together. And then we have to say, do we have a new arrange or no? Then if a new arrangement, then we have to make a new payment. Okay? Otherwise, continue. And then we have joined here. Okay? After that, we have to decide. Okay? Change or cancel or create an appointment. You have three decisions. Okay? It's not necessarily two decisions. Could be more than one decision. So if you're gonna create, you have to create an appointment. If you want to cancel, you cancel an appointment. If you want to change the appointment, you can say change the appointment. All of them join together here and goes to the end. Okay? This is how we use joint, and how we use the decision, how we use the merge, how we use the fork and swimlane and so on. But this is just a guidelines for how to draw the activity diagrams. First of all, set the scope of the activity diagram. It cannot be, you cannot draw an activity diagram for more than one process. Okay, you have to specify the process. This is the process, and this user who involved in this process. So for example, this is the process here, this is the scope. We have user 1, okay, and user 2 involved in this process, and I don't want to put another process inside it. This is wrong. Okay, just focus on one process and who is involved in this process. We call this the scope of the activity diagram. What activity is going to be there and how we connect the diagram, what decision that should be made, and if there any process are going to be executed together, then we have to use fork, and then you start drawing the diagram at the end. Okay? So this is the basic steps that you need to know in order to draw the diagram. This is an activity diagram for the following process. Okay? You want to go out with a friend. Go out with what? With a friend. Okay? Let's try to draw an activity diagram of going out with a friend. This is the process. Start with what? The process start with picking up a friend. Okay? End with what? Dropping a friend. So we know the end. This is the start. Gonna draw this. This is the start. Okay? And this is what? The end. This is the end of process. So we know the end. We know the start. Okay? This is the start. Looks like this. Full circle. And this is the end. Take into account what you will do if you have money or don't have money. So we have a decision. Money. If you have money, yes or no.